Hi, I collected all necessary parts, so I'm ready to solder my FPGA board. If I succeed, at the end of this video we should see a blinking LED. This time I'm going to show you all the steps that I have done to reach a working board. Hopefully working board. So let's get started. And sorry about my voice. Those packages contain components for all ongoing projects, such as motherboard, VGA extension card, and of course FPGA extension. Since I am still waiting for RP2350 arrival, I can start by making the FPGA board, which can be used standalone without the motherboard. I started by cleaning the PCB from dust and grease using a PCB cleaner. If you look closely, my PCB contains gold plating. I was lucky to come across a good deal at my PCB manufacturer, so they provided me with 6-layer PCBs with ENIG with vias in pads for just $2. For 5 of them. It should be easier to solder BGAs on that plate. Then I placed the board on the hot plate and I started placing components on top side of PCB. Everything except BGAs, which need additional steps. Then I preheated the board to 100 Celsius, which is around 212 Fahrenheit. I'm using a lead solder paste so that the components will align themselves nicely. And that's it! Now it's time for the hardest part, PGA reballing. I decided to do reballing of PGAs to lead balls because then it will be easier to solder them. I'm doing this for the first time, so I failed so many times that I will keep in video only ones that you can learn from them. Firstly, I tried to use my PCB stencil to do reballing. And most of you probably just noticed my mistake. Never, really never add flags to the stencil itself. Of course, balls were soldered to stencil instead of the chip. So I cleared the chip, placed flags and tried to do reballing by hand. And you may have spotted a new problem, which is too much of flags. Much better. Almost all of them self-positioned correctly with heating. Let's fix wrong ones. Great, let's clean up with isopropyl alcohol and HyperRAM is prepared. So I prepared FPGA chip. Of course, not without problems. Again, too much of flux, so let's skip that fail. I didn't give up and tried again. This time I decided to do reballing by hand. And this try took me a few hours, to be honest with you, to place them all. My camera overheated and didn't capture that my tweezers holding chip jumped moving parts of balls. So I decided to fix few of them, then solder them to chip, clean up and continue with left pads. I'm really sorry about those camera notifications that viewfinder is disabled. I've noticed them during post-production, so I removed them where it was possible. Then I realized that problem was caused by power saving enabled in my camera settings. Great, FPGA seems to be prepared, so I hit that board again and I tried soldering both HyperRAM and FPGA itself. Of course, the great imposter was me. I was pretty sure it wouldn't work correctly. But even though I started soldering the bottom side. The bottom side contains JTAG, connector and the coupling capacitors for FPGA. For more information you can follow my previous video with the design. For QFN packages it is always good practice to put flux and move soldering iron over pads. This should improve connection between chip and the pads. And we have a nice stable short circuit on the 3.3V power rail. I thought it was caused by the FPGA that jammed while soldering, so I decided to resolder both HyperRAM, which wasn't soldered correctly, and the FPGA. In a way it was necessary, because it may cause random problems in the future. Which of course required reballing again. But my patience has run out. I ordered new tools to speed up the process. And I found out that this little fellow was the root cause of the short circuit. I soldered the crystal oscillator instead of the clock generator. While waiting for new packages to arrive, I tried reballing using stencil. But it was a stupid idea. So 2 days later, I received packages that hopefully will solve all of my problems. Let's open them together. Clock generator and a new bottle of isopropyl alcohol, and reballing jig. Of course, with reballing stencils. The stencils that I ordered are dedicated to direct heating, but they are not dedicated to my jig. I've tried using them with Kapton tape, but it was a terrible experience. Again, it took me around 2 hours because many balls didn't stick. I will show you a better way of doing that later in the video. If individual balls stick together, they can be removed with a soldering iron, but you have to use tiny soldering tip. I think I damaged PCB under FPGA, and now I have a short circuit on the FPGA core power rail. So...
oh shit, here we go again.
Thanks to tips from one of my friends, I modified the universal stencil using Kapton tape to fit my FPGA layout. Then I used it only to place balls on chip covered with flags, and aligned all balls that were not centered. And it was much better. All balls self-aligned, and the whole process took me between 30 to 40 minutes. Since my previous PCB was broken, I soldered new one again. This time everything went smoothly. Power supplies check. Firstly, dry one. 5 volt is good. 2.4. It's also good. 1.8, good. And 1.1 may show a short circuit due to FPGA's low resistance on the power supply, and that's a normal thing. Let's verify voltage levels. And all good to go. I made a mistake in the design. I've added the possibility of delivering power from USB, but I forgot about 3.3 volts. This card will be mainly used on top of the MSPC motherboard to deliver all power. For now I can power it from an external source. I chose Raspberry Pico since it also works as a programmer for my JTAG adapter, so I use open source project called Dirty JTAG that I just configured using my pinouts. And tried to detect my FPGA, which was a great success. To test my board, I created a simple blinking circuit. I used Yosys with NextPNR. For NextPNR, I had to define pinout. I took pin names from my schematic. But they can also be obtained from pinout schema from Lattice website. Then I added Makefile to build my bitstream using those tools. To load bitstream, I use OpenFPGA Loader tool. Yay, PKA, I made it! This board is actually working. I'm really proud of myself. This was the first time that I ever do BGA reballing, BGA soldering, and this board is the most complex project, PCB project that I ever created. And it works from the first revision. I didn't expect that. So if I was able to do that, I think you can too. Of course, working with BGA requires a lot of practice, so I failed so many times. I removed most of them and I left only ones that you can learn from. Rest of them was basically always the same mistake. I'm really happy. You cannot imagine how happy I am right now. I think that my electronics hobby's path just level up. So thank you for today and see you in the next episode. Bye!